Okay, so in this lesson, we're going to talk about how to deduce the expression of a new series from a given series. What I mean by this is that, now before that, okay, this kind of question usually comes in the later part of the question in the Maclaurin series questions, okay? So what happens is that maybe in the first part, okay, they ask you to evaluate what is the expression for e to the power of sine x, okay? And then you have gotten, this expression, this is the expanded form, okay, for e sine x. So I have a few over here, we'll talk about them, but what I want to set into context is that for questions involving this, deduction, all right, usually the first part, they would have asked you to find an expression for a particular function, okay? In this case, this is e sine x, right? And then maybe in part 2 or part 3, they may say, hey, once you have gotten this, hence as a result, deduce what's this, okay? So I've set, the different variants, okay? In fact, there are 5 variants of this kind of questions where you could use different techniques. So these 5 variants correspond to 5 different techniques, okay, to deduce from the original expression. So we have differentiation, substitution, trigonometric identities, algebraic manipulation, and there's one more, which I don't have any more space to write on this whiteboard, which I'll show you later, okay? But the thing is, using whatever that you have found previously, okay, as you can see, I have given you multiple examples. We are going to deduce, okay, in the later part of the question. Let's pretend that, in part 3, they ask deduce e sine x, okay, e to the power of sine x times cosine x. What's the expression here? And then for this one, they're asking you to deduce the one in blue, likewise over here and likewise over here, okay? So when you have a question like that, remember that, we could use different techniques, okay, according to how the question is structured. So I won't be able to tell you what's going to come out in your exams or tests, but essentially these, although non-exhaustive, okay, but I think it pretty much fills up, I think 90% or 95% of the type of questions you can see for the deduction, okay? And usually, like I said, the question would include the word hence, so you would not be allowed to, use Maclaurin expansion or standard series to find expansions for this. You must deduce, okay, from your original equations, or rather expressions, okay? So how do we actually solve this kind of questions, all right? So let's say for a particular question, you have found out that e sine x is actually equals to this. And then in the last part of the question, they say, hence deduce e to the power of sine x times cosine x. What is the expression over here? Now, you will need a bit of intuition and observation, okay, to look at this. And then sometimes, if you will, you can actually memorize the 5 different techniques and then just see which one it fits best, right? And in this case, you're going to use the differentiation technique because when you look at e sine x, if you were to differentiate this, right, dy dx, okay, if you were to find dy dx, all right, it is actually going to be equal to this because, let's do a quick recap here, all right? So we're going to change a different color. Okay, I don't have space, so I'm just going to write here, but I'm going to erase it soon. So d dx, okay, e fx, right, is actually equals to e fx, f times f prime x. So as you can see over here, when we differentiate this guy, we get we still keep the e fx, which is e sine x, but we will find the derivative of the power. So in this case, it's going to be the cosine x, right, which is the derivative of sine x. So when you make this kind of association, then you know that, well, this question is essentially just this. So as a result, you could differentiate this guy, okay, which will give you this guy, which is what the question wants, and then since this is equal to this, then the differentiation of this must be equals to the differentiation of this, all right? So let's go ahead and just differentiate that, right? So we will have 1, which is gone, okay, when you differentiate that, then this x becomes 1, and then plus, you power down, so 2 over 2 is 1, so this is x, and then we power down this one, it gives you 4 over 8, which is half x cubed plus dot dot dot. And there you go, that's your answer, okay? So that's basically how you answer questions like this, okay? So pretty straightforward. The only challenge here is to identify the technique, okay? Now, how many marks would these questions usually be? I would say somewhere in between 1 to 2 marks, okay? Because sometimes it's 2 marks because they expect you to do a little bit more. Over here, this is actually quite straightforward. This will be 1 mark, okay?